Welcome to section 6.1. This is the first video for Pre-Calc B, and we're going to first get back into the idea of right triangle trig, which we did in chapters 4 and 5, and then we're going to talk about what happens if we don't have a right triangle. So I'm going to start with the first one. We give you a right triangle, and part of your homework for 6.1 is to be able to find all three sides and all three angles, and so that's what we're going to be working with. So off of our diagram, I'm going to start with what I know. Angle A is a 90-degree angle, angle B is 22 degrees, and side A is 5. And my goal is to be able to figure out what's left. Well, let me start with the easiest part, which is the angles. In order to find angle C, I know that a triangle adds up to 180 degrees. So if I get rid of the 90 degrees and the 22 degrees, what it tells me is that angle C is 68 degrees. Okay, and that's the easiest of them. My second step is to be able to find the other sides, and I'm going to start with side B. And I'm going to use angle B all the time because that's the angle they gave me. And just in case my math is wrong here, I want to make sure I'm working it correctly. So let's take a look. If I'm trying to find side B, I need the opposite side and I know the hypotenuse. Well, since the sine uses the opposite and hypotenuse, I'm going to set up this equation. The sine of 22 is B over 5. In order to find B, I'm going to multiply both sides by 5. And the biggest thing, you want to be in degree mode because you're putting in a degree. And when I do this, let's go 2 decimal places. B is about 1.87. Now, which should make sense because B has to be smaller than side A, so that's kind of the important part going through. Now, I'm going to use the 22 again, just in case I did something wrong in my math. And now to find side C, I know I need the adjacent and the hypotenuse. So I'm going to say the cosine of 22 is the adjacent over the hypotenuse. And I'm going to go through and solve. Therefore, side C is approximately 4.64. Now, let's talk about if this makes sense. Well, 22 is the smallest angle, therefore 1.87 should be the smallest side. And 68 is the middle angle, so 4.64 should be the middle lengthened sides. And so you want to look at your answers and say, are they appropriate? Now maybe I don't know if they're exactly correct, but are they at least in the appropriate size as they go through? Okay, and so this is kind of what we did with the whole idea of SOHCAHTOA in chapters 4 and 5. What we're going to do today, though, is to talk about what happens if my triangle is not a right triangle and I can't use SOHCAHTOA. So here's what we're going to do. Let's slide down and I'm going to show you a proof. And normally these proofs, I do one with you and then you do one on your own, but I'm going to show you both. These are in the back of this chapter too, just going through. Okay, so here we go. For the first one, I'm going to use angles A and angle B. And for the second one, I'm going to use angle A and angle C. And the reason is I want to show you how the entire law of sines came about. And so that's why we're going to go a little differently. Okay, so one triangle is where I have a triangle where the height is inside. Okay, and then I'm going to label my sides. Let's say this is angle A, angle B, angle C. And if I'm going to label my sides, side C is across from angle C, side A is across from angle A, side B is across from angle B. Okay, now I'm going to use the height to help me figure this out. And so I'm going to go like this. The sine of angle A is the height. So if I look at this angle here, the sine is the height over side B. And if I rewrite this, then the height is B times the sine of A. Okay? And I'm going to use, since I'm using angle A and B, I'm going to do the same thing. The sine of B is the height over side A. So therefore, the height is A times the sine of B. Now, because these are both equal to the height, I'm going to set them equal to each other. Okay, and I'm going to say if A times the sine of B equals B times the sine of A, then what I can do is write these as a ratio. The sine of A over side A equals the sine of B over side B. And the reason that works is normally when we solve a proportion, we would cross multiply. So the sine of A times B equals A times the sine of B. And so that's why we can go back and instead of having this multiplication, we can make a proportion. Okay? So basically I'm going to walk you through that same procedure again. The only difference here is instead of the height being inside the triangle, this time I want the height to be on the outside. Okay, so I'm going to draw my height. So here's my height. I'm going to call this angle down here A, C, and I'm going to make this top one B. So let me label my sides. This is side C, this is side B. Okay, and I'm going to do the same thing again. Now I'm going to use A and C this time. So the sine of A is opposite over hypotenuse, so H over C. And if I rewrite that, then the height is C times the sine of A. And I'm going to do the same thing with C. The sine of C is the height over side A. So if I rewrite it, the height is A times the sine of C. And then again, I can do the same thing. If A times the sine of C equals C times the sine of A, then the sine of A over side A equals the sine of C over side C. Okay, so this idea is how the law of sines came about, and that's how they used, basically, the law of sines was brought about as using right triangle trig for those that aren't right triangles. So here's how the law of sines works. If ABC is a triangle, okay, and I'm going to shorthand this a second, with sides A, B, and C, then the sine of A over side A equals the sine of B over side B, which equals the sine of C over side C. Now you can put the lengths on top and the angles on bottom. Law of sine says to me start with a sine, okay? Now the biggest thing is you'll only use two ratios at a time, which is why I'm kind of showing it to you two ways. Sometimes you'll use A and B, sometimes you'll use A and C, sometimes you'll use B and C. It depends on what you're given. So what I want to do is go through one example with you, and then I will give you, you know what, I'll go through all three. Okay, here we go. Let's slide this down. First example, let angle A be 41 degrees, angle B be 92 degrees, and C be 12 feet. Biggest thing, draw a picture. I'm going to start with the biggest angle, 92. I know that's just above a 90, so maybe it'll look something like this. So I'm going to call this my 92 degree angle, which is B. That means across from angle B is side B. The other two angles, it doesn't necessarily matter what placement is, but I'm going to put it down here. So 41 degrees, and I'm going to call this C, and I don't know C yet. But I do know that side C is 12, and I got to find A. Okay? Now the question is, what geometric condition is given? This goes back to geo. You'll notice I have an angle, a side, and then an angle again. And so this is angle, side, angle. The conditions matter more so because we want you to recognize which conditions require which law the easiest, at least. And we'll talk about it again tomorrow when we do law of cosines. Well, I'm going to start with the angles. In order to find angle C, 180 minus 92 minus 41. If I stick this in my calculator, I end up getting 47 degrees. So let me fill in what I know. Angle A is 41, angle B is 92, angle C is 47. side C is 12. Again, we're talking in degrees, so please put your stuff in degree mode. As I go through, because it's not a right triangle, I'm going to use the law of sines. And what you always want to do, and I'm going to switch colors here a second, what you always want to do, since I know that this is 47 degrees, is use the corresponding angle with the corresponding side, okay? And that's the ratio I always want to start with. So I'm going to start here. The sine of 47 divided by 12 equals, and we can decide what we want to do first. Let's just do A because that one comes first. The sine of 41 over A. So we cross multiply, and we get, let's go through this. 12 times the sine of 41 equals A times the sine of 47, and if I divide by the sine of 47, now make sure you put this in your calculator and you don't just like cancel out the signs. This actually, you need the sign to evaluate. You should get that A is about 10.76. Okay, and we're going to do the same type of idea for finding B, but we're going to come back to the 47 and the 12. So the sine of 47 over 12 equals the sine of 92 over B. And again, I'm going to cross multiply. So I have 12 times the sine of 92 equals B times the sine of 47. And I divide by the sine, and I get that B is approximately 16.40. Now, the question is, does this make sense? Well, 92 is the biggest angle, so 16.4 should be the biggest side. The next biggest angle is 47, so 12 should be the middle length, and 41 is the smallest, so 10.76 should be the smallest. And that ends up making sense. And so our goal is to use the corresponding side and angle to help us get through. Okay, so let's try another one. As you look at the next one, let's draw a picture. 85 degrees for angle A. Okay, so just below 90 ends up being, that's fine, something like this. We're not too picky. Here's 85 degrees, let's say. And so this is angle A. Side A, they tell us, is 15. B has to be bigger. So let's look at the bigger angle. I don't know which one seems to be bigger. I'm going to say this one maybe. So this ends up being 25, which gets us C and C. And this is A, and this is B. I just like to label them a little bit. Okay, well, we have this corresponding angle inside, so let's start there and try to find angle B. All right, so the sine of 85 over 15 equals the sine of B over 25. All right, if I cross multiply, 15 times the sine of B equals 25 times the sine of 85. And I divide by 15. The sine of B equals 1.66. Now the question is, how do you find an angle? Well, in order to find angle B, you're going to inverse sine 1.66. The problem is you're going to get an error, and the reason why is, let's go back to our unit circle. The highest sine value for our range is 1. The sine values only are between -1 and 1, so 1.66 isn't in that range. Therefore, you can't find the angle. So what we say is no triangle exists. Now, let's take a look at the geometric condition and see if that kind of helps us. If you'll notice, as I look at this, I've got a side next to a side next to an angle, so side, side, angle. And it doesn't matter which way you go around the triangle, it's just what's kind of next to each other. Because we don't say ASS, okay? So side, side, angle. And that's when you normally run into some of these no triangle exists conditions, so kind of be careful there. Again, anytime you get this value here that's greater than 1, you're not going to be able to find the triangle. All right, here's the roughest one of all of them. It's the idea that you have 2 triangles. And so I want to look through and kind of draw a picture. I know that angle A is 20, side A is 12, and side B is 31. Okay, so 20 degrees, let's kind of make this triangle. Let's go something like this. So this is 20 degrees, which is angle A. Side A is 12, and now I have side B. Okay, now, I know 31 is bigger than 12, but do I know that 31 is the absolute biggest angle or biggest side? And the problem is I don't. And so I'm gonna look at 2 different things. One where it's just the next biggest angle, where C is the biggest, or if I draw another picture, here's my 20 degree angle, A is 12, or where B is the absolute biggest, and so 31 is the largest length. So that makes this C and this is C. The problem is because 31 is bigger, but I don't know the angle, so I don't know if it's the biggest angle, I have to look at 2 triangles. And again, as you look at my conditions, side, side, angle, side, side, angle. And this side, side, angle condition is the one where we have all of our problems. And so the problem is I don't know is B the absolute biggest or not. So I have to look at 2 triangles. So let me fill in what I know. 20 degrees, 12, B is 31. 20 degrees, 12, B is 31. Okay, here we go. I'm going to start off the same way as I did before. I'm going to say the sine of 20 over 12 equals the sine of B over 31. And I'm going to cross multiply. And I'm going to say, all right, 31 times the sine of 20 equals 12 times the sine of B. And if I divide by 12, the sine of B is 0.8836, and you want to go as far as you can on that. So when I inverse sine, angle B is approximately 62.08 degrees. What that found is this angle here, which is bigger than the 20, but not necessarily the biggest. So 62.08. The problem is, what is the other angle for this one, and how do I find it? If I did this procedure over again, I'd still get 62.08. But here's what it comes back down to, and let me just quickly draw this unit circle. They found this angle, 62.08. Where else, though, is the sine a positive 0.88? It's in the second quadrant. And how do I find that angle? To find this angle B, I take 180 minus the 62.08 because we're really looking for the supplementary angle. And if I do this, my angle B is 117.92 for the second triangle. So that tells me this angle, which is the biggest. And it all comes back to the unit circle where we say to you, okay, if it's positive in quadrant 1, sine is also positive in quadrant 2, and so you find that angle. Now I'm going to switch colors so I don't confuse you with the rest of the stuff, but let's try and finish up the rest of the triangle. If I'm trying to find angle C over here, I take 180 minus 20 minus 62.08, and I end up getting 97.92. Okay? How do I find side C then? I take the sine of 20 over 12 equals the sine of 97.92 over side C. And I cross multiply. And I'm going to end up shorthanding this a little bit. What I end up getting is 34.75, which makes sense because it should be the biggest side. Okay, I can do the same thing in the second triangle. If I took 180 minus 20 minus 117.92, I end up getting that my missing angle is 42.08 degrees. And to then find side C, I still use my ratio. The sine of 20 over 12 equals the sine of 42.08 over side C. And I'm going to cross multiply to get that C is 23.51. And so you're kind of looking at this idea, the whole side-side angle case, you either have two options, two triangles or no triangles like we saw before. And the two triangles obviously is the most difficult. What you have to keep in mind though is this unit circle where they give you the angle in the first quadrant, you have to find the angle in the second quadrant. Okay? So last idea is this area formula, and you actually used this area formula in Algebra 2. The area of a triangle is 1/2 times the product of two sides times the sine of the included angle, and that means the angle between the two sides. And I write it out like this because really there are three formulas, and I'll show you all three. 1/2 AB times the sine of C. Or it could be 1/2 BC times the sine of A, or 1/2 AC times the sine of B. And it completely depends on what sides they give you and what angle they give you. What's nice is they're going to give you an angle and then the two different sides. And if they do that, then to find the area, we take 1/2 times 10.8 times 12 times the sine of 41, and we stick it in our calculator. And we say the area is 42, let me erase that, 42.51, and then we need our units. Feet, so feet squared because it's area. Okay, and you will have some area questions on tonight's homework, but again, they're giving you product of two sides times the sine of the included angle. That's it for section 6.1. So law of sines, we're going to give you quite a lot of practice on that today, and then we'll do law of cosines tomorrow.